Assalamualaikum and good evening to my lecturer, Professor Madya TS Dr. Muhammad Zahir bin Hassan, and all my fellow friends. My name is Muhammad HAKIMI YUSRI.
My name is SIDDIQ FAHMI bin Ahmad SANUSI.
My name is NICODERMUS JAMPI ANAK JEFFERY.
My name is SANJEEV MAILALAGAN.
Today we will present our assignment, conduction graphical analysis on heat transfer. For the content, we have introduction, design, analysis, discussion, and conclusion. I will present about introduction and design. For introduction, what is defined as a heat sink? As a heat sink is a component that helps to transfer heat away from a hot device. It achieves this by increasing the device operating surface area and the amount of low temperature fluid that flows through it. Heat sink is a device that transfers thermal energy from a hotter device to a cooler fluid medium. Air is the most common fluid medium, but it can also be water, refrigerant, or oil. The heat sink is commonly referred to as a cool plate when the fluid medium is water. To transfer heat via convection, radiation, and conduction, practical heat sink for electronic equipment must have a temperature greater than the surrounding environment. What is the application of heat sink? Heat sink are utilized with high power semiconductor device like power transistors and optoelectronics like laser and light emitting diodes, LEDs, where the components heat dissipation capability in insufficient to keep the temperature under control. So this is our design 1 and design 2. Design 1 we create with a straight cut of plate, and design 2 a wavy plate. The dimension within these two design are same. The base, the height of base, and the thickness of plate.
For the part analysis, we have two design, which is design 1 and design 2. For design 1, the difference of the design 1 and design 2 is design 1 the temperature is 314.4415, and for the maximum of the temperature is for design 2 310 and 116. Okay, for the part analysis based on the figure, the highest the temperature distribution occurs in the bottom part of the heat sink, and further from the bottom part of the heat sink, the temperature gets lower. Then the heat source spreads slowly to another part of the heat sink. Here there is a contact area between devices and heat sink, causing conduction to occur. Conduction occur when the heat released by the devices and another component of the electronic to the heat sink as known as enhanced heat dissipation. Furthermore, the maximum temperature of the heat sink is inversely proportional to the inlet wind. The higher the velocity of the air inlet causes the lower the maximum temperature of the heat sink. The number of the fin effect, the total of heat will be transferred. The greater of the fin apply, the higher of heat transfer. The effectiveness of the heat sink are measured by the temperature. The higher the temperature, the effectiveness will be higher too.
Discussion: the heat transfers away from the source. Heat pipes can also hold it in this process, but covers the components completely. In indirect heat sink contract application, heat moves into the heat sink and away from the source via natural conduction. Second thing is number of fins indicate the surface area exposed. The more surface area exposed, it lead to more heat removal. Hence, the lesser heat remains in the heat sink. Third is the rate of The rate of heat transfer is higher if the fin is thinner. Next one is heat sinks are most commonly found in CPUs in computers. For example, a Jetson Nano has the large heat sink to assist in cooling the onboard quad-core ARM A57 CPU and 128 core NVIDIA Maxwell CPU, both of which create ample amount of heat and require exceptional cooling amount of thermal throttling. The last one is active heat sink. Active heat sinks utilize forced air to increase fluid flow across the hot area. Forced the air is the most commonly generated by fan and blower or even movement of the entire object, such as motorcycle engine is being cooled by the air passive along the heat fins designed into the engine. One example of fan producing forced air across a heat sink is the fan your personal computer turning after your computer gets warm.
Okay, for the comparison, okay, for the aspect that we use is material. For design 1 and design 2 is the same, which is 1060 alloy, and for number of fin, we use 17 for design 1 and design 2. And then for the thickness of the fin in millimeter is 1 millimeter. And thickness of the sidewall in millimeter is 2.5 millimeter. Fin spacing 1.0 millimeter. So the effectiveness for design 1 is lower and for design 2 is higher. For the thermal range, for design 1 is for the minimum value is 314.415 Kelvin, and for the maximum is equal to 314.655 Kelvin. So for the design 2, for the thermal range is 310.116 Kelvin, and for the maximum is 310.694 Kelvin. So for the shape for design 1 is straight, which is flat kind of design, and for design 2 is wavy. Okay, for the conclusion of our presentation is, in conclusion, heatsink design 2 is a lot better than design 1. This is because of the thermal range for design 2 is between 314.415 Kelvin to 314.655 Kelvin compared to the design 1, which is 310.116 Kelvin to 310.694 Kelvin. So second, the efficient thermal conductivity of alloy profiles is a decisive factor of in maintaining good heat dissipation and an ideal medium for conversion of thermal energy. So third, the fin arrangement for design 2, which is wavy type of, is much better compared to design 1. In general, the wavy surface area heatsink has, the better it works. So lastly, the fin curve and bends for design 2 is better than design 1 because it's allowing for more contact with the surrounding air. So that's all from us. Thank you.